When one of the process is being executed, another process must be blocked. That means to get an updated information, many to one model corresponds to many number of user level threads corresponds to one kernel thread. Hello and warm welcome to one and all. It is Dr. Ravikumar YB, Department of Computer Science, Vidhyaashram First Grade College, MYSURU, the Temple of Excellence. In today's class, I will teach about the multi-threading models. What is the meaning of multi-threading model? In the previous session, I spoke about the threads. Multi-threading means what? Multiple threads. How these models are built with multiple threads in one model. Let me take you into the details of it. Some operating system provide a combined user level thread and kernel level thread facility, whether it may be an Android or any of these, that provides a combination of user level thread and the kernel level thread. Solaris is a good example of this combined approach. That is, Solaris operating system is an example of this combined approach of user level thread and kernel level thread. In this combined system, multiple threads within the same application can run in parallel on multiple processors, and a blocking system called need not block the entire process. What is the meaning of this? If one of the process, that is process P1, is having multiple threads, and these multiple threads, that is T1, T2, T3, T4, if this T1, T2 works on one of the core and the same T2 also works on another core or another processor, that is called as, that does not require any blocking system call. What is the meaning of blocking system call? When one of the process is being executed, another process must be blocked. That means to get an updated information, if I have one process called P1 here and P2 here, when P1 is executing, P2 must not interrupt the P1, process P1 execution, so that it completes the execution of it. Similarly, when P2 is executing, P1 must not interrupt P2. P1 must not interrupt P2, so that the completion of execution is over by the process P2. In that case, process P1 is having multiple threads. So this process, this thread can move on into one of the processor and this into another processor and this into another processor. That means what? Multiple threads are working on multiple processors so that the execution of the program is done very fast. That is the meaning of this. If that is the case, we have a multi-threading models, three types of multi-threading models. The very first one is many-to-many relationship model. Second one is many-to-one relationship model. Third one is one-to-one relationship model. What does this mean? Suppose if there is a channel like user level thread and this is a kernel level thread. In this case, whenever there is a thread, multiple threads are there, that is T1, T2, T3, T4. All these threads operate together on one single thread in the kernel level. Then we say this model as many-to-one model. In case of this many-to-many model, we will be having one more type of thread here. All these threads are combined together to form and work on multiple threads at the kernel level. This is called as many-to-many model. Many-to-many model. This is called as many-to-many model. This is called as many-to-one model. When there is a one-to-one relationship, the number of resources required to execute will exceed the total number of resources available in a system. That means for every one thread created in the user process, we must have one corresponding kernel thread. So this is very tedious and more expensive in terms of number of resources required to execute. If that is the case, let me take you into the details of these models one by one. First one, many-to-many relationship model. In this case of many-to-many model, multiple access any number of user threads onto equal or smaller number of kernel threads. As I told you here, many number of user threads are equal to or less than the number of threads available in the kernel threads. That means the number of threads created in the user space is equal to the number of threads in the kernel space is also possible, or less than that is also possible. Suppose if there are 3 threads in this user kernel space, we can have 3 threads in the kernel space, or we can have 2 threads in the kernel space, or 1 thread in the kernel space. Then it becomes many-to-one model. Suppose if 3 to 2, then it becomes many-to-many model. So that is what is going to be explained here. The following diagram shows the many-to-many threading model where 6 user level threads are multiplexing with 6 kernel level threads. Please see to the diagram now. Let me show you the diagram first. In this case, we have thread library here. In this thread library, we have a set of threads here related to process P1. Process P2 is related to 3 threads. So all these threads are combined together to form 6 threads in the kernel space. So we have a total of 3 plus 3. 3 threads belong to process P1 and another 3 threads belong to process P2. So all these threads are combined together to form a kernel space. So if that is the case, we can have many-to-many relationship model like this. So if you look at this diagram, you will see that the many-to-many model, developers can create as many user threads as necessary, and the corresponding kernel level threads can run in parallel on a multiprocessor machines. The same thing I explained earlier, that is, it can run on multiple machines. That is this one. Thread as many threads as they require, they can create. And these multiple threads can run on multiple processors. So that is why we call it as many-to-many relationship model. This model provides the best accuracy on concurrency, and when a thread performs a blocking system call, the kernel can schedule another thread for execution. When one of the thread is blocked, it can consider the other thread to perform the same action. That is, when thread T1 is performing certain operations called OP1, if it is blocked, thread 3.2 can continue the execution of operation 1, so that there is not halting of the system. This is done by the many-to-many model. So by doing this parallel operation, the accuracy also increases in case of many-to-many model, so that the performance of a system also increases. If that is the case, what about many-to-one model? Many-to-one model corresponds to many number of user level threads corresponds to one kernel thread. That is the meaning of this. This means many-to-one model maps many user level threads to one kernel level thread, and the thread management is done by the space in the thread library. That is called as this. When thread makes a blocking system call, the entire process will be blocked. Only one thread can access the kernel at a time. So multiple threads are unable to run in parallel on multiprocessors. What does this mean indicates? When one thread makes a blocking system call, the entire system will be blocked because we have only one thread in the kernel space. We have multiple threads here in the user space. When multiple users tries to access the same thread, what happens? When one of the call is blocked, we cannot proceed further. The entire system is blocked. That is the meaning of this. So if that is the case, many to one model can be represented in this form. We have thread T1, T2, T3 corresponds to this thread. T4, T5, T6 corresponds to this thread. So if there is any blocking system call made by this, it has to wait for process P2 to complete so that the other resources of P2 may be utilized for this process P1. That is the meaning of this. So if the user level thread libraries are implemented in the operating system in such a way that the system does not support them, then the kernel threads use the many to one relationship. This is also very expensive compared to many models. So moving on to one-to-one model, for every one thread created in the user space, we require one thread in the kernel space. That means what? Mapping from user level thread to kernel level thread increases. That eventually increases the number of resources required to execute the applications of the application users. If that is the case, one-to-one relationship of user level thread to the kernel level thread, this model provides more concurrency than the many-to-one model. It also allows another thread to run when a thread makes a blocking system call. What does this mean? I am using the word blocking system call very often. What does this mean? See here. When one thread is there in the user space and another thread is there in the kernel space, when one of the thread is blocked, another thread can make use of this kernel space into this, so that another thread which is available in the kernel space may also be utilized. Then it becomes one-to-many, but we do not have a one-to-many model in this operating system. So what do we have? When one of the process is blocked, other process can utilize the threads available in the kernel space. That is the meaning of it. When multiple threads to execute in parallel on a multiprocessors, disadvantage of this model is that creating thread requires the corresponding kernel thread. That is what I am telling here. When one of the thread is created in the user space, we must have a corresponding kernel thread. That increases the number of thread creation. So Windows NT operating system to Windows 2000 uses this one-to-one relationship model. In the earlier days, we used to see that Windows 2000, Windows NT, OS/2, all these are different types of models which we had been observing. All these kind of operating systems had been using this one-to-one relationship model. So you can look at the diagram how it works. The entire thing, this corresponds to this entire thing corresponds to this. So there is a one-to-one mapping for every thread created in the user space with the thread in the kernel space. So with this, I hope you all have followed really very well about the mapping of user level threads with kernel level threads. Suppose if you have any questions with reference to the topics I have discussed, I will be available in college. Come back to me. I will definitely help you in this regard. Thank you very much. Thank you one and all, my dear students.